The most common system uses a combination of ground and airborne equipment. Ground equipment transmits signals to airborne receivers, and pilots then determine and control ground track on the basis of instrument indications. The Very High Frequency Omnidirectional Range is abbreviated VOR.
Military and naval aviation uses a comparable system which transmits data on ultra-high frequency called Tactical Air Navigation, or TACAN. Most VOR sites also have an operating TACAN. The combination of the stations is called a VORTAC. A VORTAC has two distinctly different transmitters and antenna systems at the same site. For now, our discussion will deal only with the VOR, and we'll refer to both VORs and VORTACs as VORs. The VOR station is easily spotted from the air. It is a small, low building topped with a flat white disc which houses an antenna system. This is the sectional chart symbol for a VOR. Here is the symbol for a VORTAC. The frequency for the VOR is shown in a box near the station symbol. Sectional charts do not show TACANs. A compass rose is centered on the VOR symbol. The compass rose and the VOR are aligned with magnetic north. Everything else on the sectional chart is oriented with true north. In sections of the country where there is considerable magnetic variation, the compass rose appears to be tilted. Pilots can select 360 different courses when navigating with reference to a VOR. Courses emanating from a VOR are called radials. Radials are defined as magnetic courses from a VOR. This is the 360-degree radial extending north from the VOR, and this is the 180-degree radial extending south from the station. To keep your semantics straight, radials are the spokes which radiate from a VOR, and bearings are the courses flown either to or from a VOR. For that matter, bearings and courses are the direction flown to or from any point on the surface. The Airport Facility Directory will show unusable radials of a VORTAC, such as the Helena VORTAC in Montana. The 035-degree through the 050-degree radials are unusable below 12,000 feet beyond 25 nautical miles, among others. VOR signal reception is line of sight and varies according to the altitude of your airplane. Obstructions, or the curvature of the Earth in the direct line between the airplane and transmitting station, will block out VHF signal reception. At 1,000 feet above the altitude of the transmitting station, normal reception extends to 40 nautical miles from the station. The reception range is proportionately less at lower altitudes. VORs are identified by a 3-letter Morse code shown on charts. If a VOR is transmitting while undergoing maintenance, the station will either transmit the Morse letters TEST or remove the identifier altogether. This is done to inform you that the VOR signal may be inaccurate or unreliable, and the station should not be used.
Listening to the signal to identify the station is extremely important. First, be sure the correct station is tuned in, and second, be certain the station is operating normally. The accuracy of the VOR system depends on proper adjustment of both the transmitter and the receiving equipment. With the transmitter and receiver operating normally, accuracy is generally plus or minus 1 degree.